Hello, everybody. It's Jeff Einen and Stan Nabazzi from Michael's Energy, and we're going to cover a new opportunity for utilities and their customers that we're unleashing here in the next coming months in 2023. So at Michael's here, we deliver a decarbonization training session for the Association of Energy Services Professionals. We call it the three-legged stool of decarbonization. And the three-legged stool includes reliability, affordability, and clean energy. And the issues that we're seeing are that reliability or the clean energy is sprinting ahead of the other two, and we're starting to have issues with reliability and price instability, particularly because a lot of thermal energy or dispatchable thermal energy plants are closing down. And we're also concentrating our fuel resources on natural gas, which is volatile and high priced at times, as we've seen. And the fuel availability is becoming an issue along the East Coast and the Northeast, as we saw, this last winter, Christmas of 2022, and before that in the winter in Texas a couple of years ago. We also have a duck curve as solar energy production is increasing rapidly. This is in California. We can see times of overgeneration in the middle of the day, in the spring and the fall, and then we have a very steep ramp in the early evening of here at 5 gigawatts per hour, which is a very steep ramp, and that's the equivalent of 5 nuclear power plants coming on in just an hour. That requires a lot of hot spinning reserve to come up to speed that fast, and it's also risky from a fuel availability standpoint. So that's California, but it's also moving to it's already in other Southwest states, including Arizona, and coming to Colorado, and moving east to the Eastern Interconnection. This is a plot of new generation being installed in the Mid-Continent Independent System Operator region, which is from Michigan to Manitoba, the Dakotas, and down to Louisiana. And we can see that the yellow additions, which are solar, are increasing rapidly in just the last couple of years. We've got like 14 gigawatts of solar energy coming online. So the result is the duck curve is moving, everywhere where solar penetration is increasing. The good news is the period of risk is fairly short, but the risk is getting higher, just like it is in California. So we're going to talk about solutions for that today. One of the things that utilities need to take a different perspective of serving customers. So for the last 120 years, in the 20th and early 21st century, utilities have always planned to meet customer loads, 20 to 30 years out, and provide enough capacity, generating capacity, transmission, distribution to meet those loads. As we increase intermittent renewable energy supplies with solar and wind, we need to reverse that line of thinking and use customer facilities and loads as flexible loads to almost follow the supply. So it's like we need to look at buildings as flexible loads that can meet supply rather than vice versa, or at least meet in the middle. And so we're going to talk about one way to do that today. And one way to do that is with thermal energy storage, which offers a tremendous opportunity for flexible loads. Compared to batteries, it's a lot cheaper and simpler. It's water or salt water or hydrated salts and blow molded plastic. And so it's just kept in containers. It can be used for all sorts of loads. We're going to talk about a couple of them here extensively. The lifetime is a lot longer than electric batteries, up to 20 years of cycling every day versus 4 or 5 years for electric batteries. Another advantage of thermal energy storage is energy efficiency. So systems can be operated at night or charged. The PCM can be charged at night when conditions are cooler, and the system operates more efficiently that way. Plus, the load-serving equipment can operate at its optimal efficiency rather than following the load every minute of the day. So there's two ways to improve efficiency that way. There are also non-energy benefits, including temperature stabilization and bridging for short-term outages, whether it's equipment outages or power outages. PCMs or phase change materials can cover that outage for up to a few hours. Another thing, finally, is there's no supply, or there's very little supply chain issue. As these materials are sourced and manufactured in the United States. They're not mined all over the world and shipped to China for manufacturing, and then they're processing, and then elsewhere for manufacturing, and finally shipping back to the United States. So what are the opportunities for thermal energy storage? Well, right now, frozen storage is an optimal opportunity, whether it's cold chain distribution or food processing or retail, grocery and convenience stores. Down the road, as phase change materials are advanced in their design, we can see temperatures that are higher in the refrigerated space. So all those same cold chain and retail will be applicable or be available for phase change materials. Chilled water is another opportunity that's been around for decades. And again, the improved phase change materials, if we can raise the temperature up to an more efficient operating point of around 40 degrees instead of 25 degrees, we'll get a lot better energy savings and be a lot more cost effective. And then telecom and data centers will be another opportunity just to have phase change materials at right around operating temperatures, space temperatures. So with that, I've seen great opportunity in this and wanted to be a part of this development in the country. And we are fortunate to bring on an expert in this field, and his name is Stan Nabozny. And I'm going to turn it over to him now to talk about the state of thermal energy storage. Stan?
Thank you, Jeff. And I bring about a decade of experience with phase change materials, using it principally in load shedding programs for utilities. And I've been up to that. I've been using it, I should say, in various countries around the world. I'm going to tell you a little bit about that in just a moment. I am a patent holder for thermal energy storage, and I'm your resource basically for demand reduction, load shifting, energy efficiency, designing PCMs, and more. Okay, so that's why I'm here at Michael's Energy. What I'd like to talk about first is thermal energy storage and how it's used around the world. And I'm going to start by just talking about Japan. Now, you may or may not be aware, but the Japanese government has seen the energy transition coming. I think we all see it. I think you saw it in Jeff's slide with the duck curve and the amount of gigawatts coming on board in just 3 hours in California. It's enormous, and it's changed radically in the last couple of years, and it's going to get worse. And so Japan has seen all this, and they're managing the energy transition by leading. Okay, they're actually going to microgrids. They've made that decision. They've hired Kyocera, a big electronics company, plus other companies, and they're putting together a very sophisticated microgrid system with city-level controls and building-level controls and thermal energy storage. I was fortunate to work with Kyocera last year in March to get their first thermal energy storage cold storage facility on the ground. And they're using that to manage their load, especially between the 4 to 9 p.m. window, which is that window where the duck curve is most prevalent. Now, South Africa is another example. And just to mention, I think many of you may already be aware that they're doing serious load shedding now. I think they're up to step 7. They have an 8-step program. Step 7 is 41% of the generation of the country is down. It is not working. So 41% of the time, customers do not have electricity. Businesses are closing. They have massive problems there with grid reliability. And that's an example of a country that really isn't leading. They're not being proactive. So I really have a bit of a dichotomy here between, if you will, Japan on one side and South Africa on the other, and where is and how thermal energy storage is being used in South Africa in that situation to preserve the food. Okay, they're using it as a battery backup, if you will, to preserve the food. And so, this dichotomy between Japan and South Africa leads me to a question about the United States. What is it that we're doing here to lead the energy transition? Because if we're leading the energy transition, then we're going to start looking at innovations the way Japan is and integrating various innovations together in order to preemptively prevent problems from happening instead of waiting for them to happen and then reacting to them. So I think that's very, very important for us to consider. And I think thermal energy is one solution to the duck curve that we should all consider. Looking at what's happening in the United States, just one quick example is Lineage Logistics. They're the largest 3PL cold storage company in the world with over 400 locations. I was fortunate enough to work with them to get their first cold storage facility on the ground, and basically they're looking at it to shift load. They're also putting solar everywhere along with other innovations, and they're going to be, at least their goal is, by the end of 2025, to be the fifth largest self-generation company in the world. Okay, so they're going in the right direction. They're being preemptive and they're leading. So is Walmart. They have a project called Project Gigaton, and they're putting thermal energy storage in place in their new builds, their new cold storage facilities. And US Cold is another adopter, if you will. They're also using it as well. So the question is, for you, where do you begin? And my advice is to begin with industrial refrigeration. Now, why industrial refrigeration? Because there's more consumption per cubic foot than any other utility load. I think that's the one thing to look at when you're looking at grid resilience. How do where do you start? You start with your largest loads. And the technology, as Jeff mentioned, it's green. Okay, it's green technology. It's not like a Tesla battery. There are no disposal issues. It's a 20-year life and protection. So, this is there to enable, and I'm going to show you some pictures here in a moment, but it enables temperature protection for the food. It creates grid resilience because we can shift load from that duck curve period, if you will, to nighttime. And it's about half the cost for it's half the cost for the same storage compared to a Tesla battery. However, you have to consider this. A Tesla battery you're going to replace 4 times. Okay, in 20 years, you're going to use this for 20 years. So it's really, in terms of life cycle costs, probably 6 to 8 times as cost effective as a battery. And most importantly, we now have with the IRA a 30% tax credit. So what that does is that brings the payback period for an industrial client to about 3 years, and it takes that IRR, which is what they pay attention to, into the 20% range, which is what is going to help this technology get adapted. So in terms of an example, what does it look like? There's a picture of it. Okay, so this can be mounted on a ceiling in a rack system. It's food safe, environmentally friendly, good heat absorption. And so we want to mount this fairly high in the rack system. And the installation does not disrupt operations. And I think we have a second picture, Jeff. You can just scroll to that one. Yeah, so there's a picture in a rack system in a cold storage facility, fairly easy to install. And if we could go to the case study, because I want to just show you what this can do. Okay, so this is an example of a 30,000 square foot facility. And the average load shift, as you can see, and this is what we're doing in the summertime, is this is an average shift of about 200 kW, okay? And on top of the load shift that we're doing, we're also getting an efficiency improvement because with this material in the freezer, we're actually able to have refrigeration run more efficiently because it's more efficient to charge these cells at nighttime. The external ambient temperature is lower, and so you get an efficiency savings as well as the load shift. So there really are 2 savings pathways with this technology. And so that said, let's go to Michael's Energy and how we can help you. And I think our intention here is pretty simple. We want to help you lead the energy transition. And so do you want to, for example, let's just say 50 megawatts of load. We can actually go into your utility area and determine the utility scale. And if you want to find 50 megawatts or 100 megawatts, we can go and find that for you in your utility districts, okay? I know that you're looking at structure upgrades. Okay, and we can actually help you avoid those costs by looking at this utility scale and how we can actually, help you take that load and shift it to nighttime. And of course, we provide the customer level engineering and analysis and design. We help commission. We do the M&V and the monitoring. So, we're here to help you implement technologies that can help make a difference on the grid.